Hello guys, welcome back to Math Zone African Motives, still on our mathematics for grade 11. This is trigonometry. We shall have a focus on the trigonometry question that is an exam type of a question that we're going to focus on. So as we can see, these are the questions that we were given. So we shall try by all means to attempt this quickly and see how we're supposed to have answer these typical questions, 21 marks for everything. All right, so like I said, this is an exam type of a question that we are having here. So given on question 4.1 in the diagram below, we've got the point P in this case, all right? So there is a point P here given as x minus 24, which is the one here, is a point such that OP is 25, which is 25 units. The length of OP, which is this one, is given as what? As 25 units. All right. So what you're actually having is that if you are to join from this point, you draw a vertical line, a straight line, remember a vertical line, straight to this point. You are going to see that you're going to formulate a right-angled triangle in that case. So this line that we are given, the length of this line is representing what? The hypotenuse in that case. All right. So this 25 is representing what? The hypotenuse. So we have the length of the hypotenuse there. All right. Then we are also given, and the point R is given as 12, 0, which is this point. All right. And angle ROP is given as angle beta. This is from R at O to P, this angle that is given as beta. Then we are given that this angle beta that we are having is an angle that is greater than 180, but less than 270. As you can see, the interval from this point to this point, that is where our angle lies in this quadrant. And we know that at this point it's 180, this is 270. So it's in within 180 to 270. All right, so that is the information that we're given. So I just want us to analyze the diagram first. What does it mean? From the point P, we have the x value and the y value. Remember, the point is given in terms of x and y. So there, we do not have the value of x, meaning to say the distance from this point up to this point, this distance, we do not know. That is our x values. But we have the y value, the one corresponding to the y is given as what? Is given as a negative 24. So it means this length is given as what? Negative 24. The whole of this distance that we are seeing here is 24 from this up to this. So the negative is just to show that the y values down here, they carry a negative. But as we go up, if it was like this, the y values, they are a positive up. So that is the purpose of the negative. But here, the length is what? Is 24. All right, so that was the information. So the first question is 4.11, calculate the value of what? Of x, and that is 2 marks. So like I was saying, if you had to check, we have got a right angle triangle that we have completed here. So from this right angle triangle, how can we calculate the length of the third side given two sides? We are back to our Pythagoras theorem in that case, right? So remember what our Pythagoras theorem states. It says that we can determine or we can calculate the length of the third side from our formula. We add x squared plus y squared. We must get the hypotenuse squared. So we've got x values, y values, and the hypotenuse given as r. So the x is the one that we want. So we're going to write this as x squared plus the y value. The y value is the one that we have on the y-axis, which is this one, minus 24 squared. Yes, you can write as minus 24 squared, but you can just even write as 24. The distance there is 24. The minus, like I was saying, it is just that we are referring down as we are going down. All right? So this minus does not even affect us. So this is equal to r squared. What is our r? The hypotenuse. So the hypotenuse there is 25. So we are going to obtain, we are going to have 25 squared. So that's x squared plus, from your calculator, this is going to give us 576 is equal to 625. So to find, this is x squared, sorry. So to find the value of x, we're going to have x squared transpose the positive 576 to the other side. It was a positive. So the moment a number jumps the equal sign, what happens? It carries a negative. So if it was a positive, it is going to change its sign to a negative. So that means we are going to subtract 576 on this side. You are going to subtract 576. That's the idea. So what are we going to obtain? If we subtract 576, we are going to obtain 49. So if x squared is equal to 49, what about the x? How do we remove this square that we are given there? To remove the square, we introduce the square root. So the square root is there to neutralize the square root is there to neutralize this square, to remove the square. So we are going to remain with x, which is equal to the square root of 44, that's plus or minus a 7. So we've got two possible values of x. Why? The x values can be positive on the right-hand side, or they can be negative on the what? On the left-hand side. So in our case, our x is found on the left-hand side. So this must be a negative value. So we're going back here. We take the one that is a negative. So therefore, our x is supposed to be what? A negative 7. You are supposed to test your values, to test your answer on the diagram, on this diagram. Where is your triangle drawn? If it was drawn this side, it means our x is going to be a positive value. We are on the positive side. But on this side, our x values are negative. Even if the diagram was on top like this, x is still on the what? On the negative. It is only y this time that can be a positive, because as you consider on this diagram, y is above the x-axis, so it's going to be a positive, but x will remain as a negative. So that is the value of x, which is what? A negative 7. So that's how we could have calculated this. All right, 4.12, we are now given determine the value of each of the following without the use of a calculator. Without, meaning to say the calculator is not required. All right, sine of beta. What is going to be the sine of beta in that case? All right, so this is 4.12. Let me just even write it here. It's gonna be fine. Then the rest I'm just gonna write on the other side. So this is 4.12, the first part, which is of A in this case. All right, so the sine of beta, as we can see here, we are from a right angle triangle. And like I said, the right angle triangle, from our mathematics grade 10, we know the application of our trigonometrical ratios from our SOHCAHTOA concept. From this SOHCAHTOA concept, we understand that the sine is given as what? The sine of any angle is opposite over the hypotenuse. So that means the sine of beta, in this case, the sine of beta is going to be given as what? The opposite over the hypotenuse of what we are given. So what is going to be the value of sine beta? From this, let us substitute what we are given, the opposite, according to this beta. But what you do, like I said, guys, we talked about this from our grade 10, we say the angle, this one is just indicating the exact angle. But when you are taking the ratios now inside here, you consider the angle that is inside of the triangle, the reference angle, this one that is inside, it's called the reference angle, the acute angle that is inside of the triangle, this one, which is your what? Your reference angle. So you take your angles according to that. According to this angle here, what does this side represent? That is our opposite. They are opposite to each other. What about x? This angle of 90 degrees and the angle that we are talking about, this one, they are adjacent to each other. They are sitting together on this line. So you've got the adjacent and also what? The hypotenuse there. All right. So that's the idea there. So meaning to say, according to the ratio that we wrote here, remember we said the ratio of sine is opposite over the hypotenuse. So according to this, what is our opposite? Our opposite is what? Negative 24. So this will be negative 24 over the hypotenuse, which is what? Which is 25. So that will be negative 24 over 25. That was the idea of the question. All right. Then we move on to B, cos of 180 minus beta. All right. So what? How can we simplify this? The cos of 180 minus beta. All right. This is B part. All right. So this is the item B. So we need the cosine of 180 degrees minus beta. Remember there, we are supposed to use the reduction formula from our reduction of angles. Where do we have, what is the indication first of 180 minus beta. What does it mean? All right. This one is not about where the diagram is. What does that part mean first? What does it mean? All right. We know that in the first quadrant, we talk about the reference angle as it is. In the second quadrant, we have got 180 degrees minus the reference angle. In this quadrant, 180 degrees plus the reference angle. In this quadrant, 360 degrees minus the reference angle. Here is just the reference angle that you're given. So here we need a condition of cos 180 minus beta, meaning to say we are considering when it is a condition, when it is in the second quadrant, that's where 180 minus the reference angle lies in the second quadrant. And what is the ratio of cos in the what is the properties of cos? How do we take cos in the second quadrant? All right, we are back to the cast concept, all right? From our cast concept, we will understand that in the second quadrant, this is the quadrant of 180 minus the reference angle. It is only sign there, which is a positive. Only sign. So what is going to happen with cos? It means cos at this moment is a negative. Tan is also a negative of what? Of the reference angle. What you are subtracting there. So what it simply means, the sine of this is going to be equal to the sine of the reference angle. But when it comes to the cosine of 180 degrees minus the reference angle in this case, it must be equal to what? Because in this quadrant of sine, cos is negative. So it's going to be minus the cosine of what? Of the reference angle. That is the idea there. That is the idea. Cos is what? A negative there. So meaning to say this, before we simplify further, we saw that cos in the second quadrant, it's a negative. So this is minus the cosine of what? Of beta. This our reference angle now, just like this part that we were having. The cosine of what? Here, the cosine of 180 minus the reference angle. The cosine of 180 minus beta. So beta is representing our reference angle, just like this case. I'm not saying this is our reference angle, the diagram. No, according to how you are given here, you take it that way. But now you have to consider back to the diagram. This scenario here, guys, it's not of this diagram. If you take it here, you'll be confused because it does not make sense. This, where we are in this quadrant, this is the quadrant of 180 plus a certain angle. 180 plus the reference angle, like this. Like what I was explaining here in the third quadrant. So you don't take it to the original diagram that you're given there. You'll be confused. You take it here from this understanding of our reduction angles. How do you reduce cos 180? It's like you are given, the sine of 180 degrees plus x. What is the equivalent of sine 180 degrees plus x? 180 degrees plus x is in the third quadrant, and in the third quadrant, sine there is a negative because it's the quadrant for what? For tan. So it's going to be minus sine of x. So they, instead of them writing x, they are now writing as beta. X and the beta are the same. These are just Greek alphabets. These are Greek letters that we are talking about. As we are used to x, y, a, b, and this. But the Greek, it's beta, alpha, theta, and so on. So don't be confused with this, all right? It's just the same thing as what or how you understand your x. That is the idea there. Okay, this is it here. I'm just going to simplify this further. Let me try to remove this part so that you do not confuse with where we are now. So I said the first thing is to consider your reduction formula so that you obtain the equivalent of what you are given here. Then after that, you are now using the diagram. We have said the cosine, the ratio of cosine is given as what? From these ratios that we wrote here, the cosine is adjacent over the hypotenuse. So we are supposed to have the ratio of sine of cosine beta as the adjacent in this case, as the adjacent over what? The hypotenuse. So let us take on our diagram, but take note already we have got what there? A negative. So you're going to have negative of cos beta. Okay? Our cos beta is what? According to this, we said adjacent. The adjacent is what? -7, the one that we calculated, over the hypotenuse. So it's -7 over what? Over 25. That is the ratio there. So it's going to be -7, the adjacent, over the hypotenuse, 25. So what are we going to get at the end? Negative is what? It's a positive. So that's +7 over 25. Just like that. Just like that. All right? So you have to understand the application of your ratios first to reduce them before the simplification. It is the same thing as this one. They are asking us to calculate the value of tan squared minus beta. Tan squared minus beta. So before answering the question, this is C, let me just answer it here. Before you answer your question, you have to ask yourself, what is this representing minus beta? It's a negative angle, that one. All right, we understand that this square, this square that we see, it's not a big deal, that one. We know that this represents everything to the exponent of what? 2. So it means the tan of minus beta like this, everything like this to the exponent of 2. That is what it means. The whole tan as it is being raised to the exponent of what? Of 2. But my question is, what is the indication? What is the equivalent of what? Of this part here. What is the equivalent of that? From our negative, this is a negative angle here. Remember, from our negative angle, this is the angle that is found in the third quadrant. If this angle is minus x, in the third quadrant, this quadrant is for what? For cos. Remember, from our cast concept. In the third quadrant, where we have a negative angle, it's only cos which is positive there. So what does it mean? Tan is a negative. What about sine? It's a negative also. So it means this tan of minus beta, this one, it is equivalent to minus tan. So it's minus tan of what? Of beta squared. Minus the tan of beta squared. So it's minus, what is the tan of beta? We are back now to our SOHCAHTOA concept. Remember, we talked about this SOHCAHTOA concept. The tan is opposite over the adjacent. Opposite. According to this, the opposite we said is what? Negative 24. So that's negative 24 over the adjacent, which is what? Negative 7. So this is what we are going to have. This is it. But the whole of this is being what? Raised to the exponent of 2. So whatever that we are going to get here must be raised to the exponent of 2. At that stage, guys, even if they say do not use a calculator, don't even hesitate to use your calculator. No one is going to even understand what happened from this stage. They just want the answer there. So no matter what you're given there as a statement, do not use a calculator, this and that. Just use your calculator. All right. So this is going to give us 576 everything over 49. That's what you're going to get from your calculator. Just raise everything to the exponent of what? To the exponent of 2. Do not hesitate to do that. All right. Then 4.13, they are now saying here, all right, let's understand this question, guys, here. T is a point on OP. Take note there. T is a point where? On OP, such that OT is 15 units. All right. T is found on OP. Okay, let's check our diagram. This is our diagram here. We were given the distance from the point O to the point P. And they're saying along this line lies a point called T. So we do not know. Maybe the T is here. We do not know where this T is. We do not know. But it's found on OP, on this line, along this line. That is where it is found. That is where T is found. That is the condition. It lies. A point to lie on a line, it means it's found on that line. But what they did here, what is that? They just gave us the length of OT. This is the length. If you're given OT is 15, you are given the length there. So they gave us the length from point O to point T. That it's 50. Now it's 15 units. Remember, the whole of OP was 25. So now we are no longer using 25. We are using this from O to P. They are saying it's what? It's 15 units. That is the question. That is what you're given there. Okay. Let's understand the question. Let me quickly remove this. Okay. Let us get back to the question here. The question is, show that the point T that we are talking about, that we do not know exactly where it is. it is supposed to be minus 21 over 25. It's minus 72 over 5 without the use of a calculator. We are supposed to show this. Be very careful, guys, when attempting your questions. Understand the information that you're given there. T, it's a point found on line OP, which is true. Now, we are given the length, only the length. Let us go back to our diagram. I want us to analyze something. This is what we only have here so far. So far, we only have this from the point O to P, this distance, which is 15 units. That is the only thing that is there so far. Okay. We all understand this distance was minus 7. We talked about this distance for x. Let me just remove this. We know this is our adjacent, and that distance was given as minus 7. Don't worry about that. Okay. So if we are to take a complete diagram this time, from the point O to the point T, we are no longer at P. Remember, we are focusing with the T now. We want to calculate the coordinates of T, just like what was given at what? At P. We calculated the value of x at P and we got minus 7. So it means the point P is given as x, which was minus 7. The value of y is minus 24. That's what they want us to do on T. So meaning to say T, we are supposed to find the x value there and what? The y value. We are supposed to prove this. Okay, I want you to see something. If you join, just like what we did here, to form a right angle triangle from the point T now, we are joining back to the horizontal line here like this. We are formulating the same properties just like what we had before. What am I trying to say? These two triangles, guys, look what is happening here. These two triangles that are being drawn, this bigger triangle and this smaller triangle here, they have same ratios. They're taken from the same, we are talking about the same angle, guys. There is no way that here, this is the same angle here. Okay, let's assume that. Okay, let's assume that this angle in between here is 60 degrees. So if I draw a triangle like this, right? I want to do it like this. I want to have it back here, right? So it's going to be like this. All right, I want to have it the same way, guys, like this. So let's say I've got this triangle here, you see it. And this is the common angle, this one. And this angle here is 30 degrees. Okay. There is no way that the sine of this 30 degrees of this triangle here will be different to the sine of the bigger triangle of the same 30 degrees because they are taken from the same point. So they have the same properties, right? What you had on the bigger and what you have on the smaller is the same angle taken at the same point. So if they have the same properties and is the same angle there, because here you're supposed to analyze in a way that you understand this. This angle that we are taking here is still common angle. So there is no way that this common angle that we are talking about, this one, the common angle that I've indicated here, there is no way that this angle here is going to have different properties while it is the same angle that we're talking about. There's no way. So what am I trying to say? I'm trying to say that the sine of this angle from what we obtained using this bigger triangle is the same as the sine of this using the smaller triangle. So meaning to say our properties, they are not going to change according to the same angle, this one. This is our opposite side, just like this. This is our hypotenuse side, and this is what? And this is our adjacent. So what we are given only here is the hypotenuse. We are given the length of OT. So we only have the hypotenuse there. We only have the hypotenuse. We do not have the X value. We do not have the Y value. These values are not there. That's the point T. So we have to find the x value, which is our adjacent, and the y value, which is the opposite. So how can we do that? We have to equate the ratios that we are given. So from our soccer tour, we've got the ratio of sine. Have we calculated the ratio of sine before? Yes, we have the ratio of sine here. Remember, we calculated the ratio of sine here before. We got the sine of beta is what? Negative 24 over what? Over 25. So remember, we got this ratio before. All right, so this is 4 point what? 4.13a. All right, 4.13a. All right, so this is it here, guys. We calculated the ratio of sine beta before, and the ratio of sine beta from opposite over the hypotenuse, it was negative 24 over 25. Taking from what? From the bigger triangle. Now from the smaller, let us calculate the ratio of the same sine of beta. The same angle beta here is the same angle beta. But now from where? From the smaller triangle, this one. We want to calculate the same ratio. Opposite over hypotenuse. What is the opposite in the smaller triangle? The opposite here is what? It's y, the one that we are supposed to calculate, over the hypotenuse. As we can see, the hypotenuse has changed because we are only moving from O up to T. So the hypotenuse is now what? The hypotenuse is now 15. So that's y over 15. So this ratio of sine, these two ratios, they cannot be different. It is the same sine that we are talking about. So how can they be different? It's impossible. There's no way that the sine of beta, the sine of 30 degrees gives us 0.5. Another sine of 30, it gives us 0.3. There's no miracle like that. This miracle is not there, does not exist. These two, they are the same. The sine of beta is equal to the sine of beta. If it is like that, I can formulate an equation because I'm saying the sine of beta is equal to what? The sine of beta from the second one, from the second or from the smaller triangle. So this one that I got here, negative 24 over 25 must be equal to, that's negative 24 here over 25 must be equal to what? To y over 15. So how can I calculate the value of y now? Remember, what I want is the value of y. You can do your cross multiplication, is fine, or you can just multiply by 15 both sides. To remove this, it's a decimal, it's a fraction. So multiply by this number, which is on the what? On the denominator. This will cancel. So meaning to say y is going to be equal to the product of this. 15 times what? 15 times negative 24 over what? Negative 24 over 25. So what are we going to obtain? That is the case. That is the case then. So you're gonna get negative 72 over 5. If we simplify this properly, please do that properly on your calculator. All right. Then let me just try to do this quickly. Let me just try to show this part of the screen here. Why is it that I'm having two calculators? All right, I hope you can see the screen here. All right, so this is it. 15, just multiply 15 times, all right, 15 multiplied to 2. Gonna take this negative 24 over 25. All right, my calculator is just a little bit slow. That's negative 24 over 25 like this. You're gonna get negative 72 over 5. All right, so that's the same situation that you're gonna do to find the value of x. So if we check here, we calculated y. So to find x, or let me just write properly here, y is equal to negative 72 over 5. All right, so to find x, as we can see, x represents the adjacent. So to include the adjacent, we must have what? The cos, because we need adjacent over what you're given, the what? The hypotenuse. So we're going to take the ratio of cos. If we calculated the cosine of beta before, the cosine of beta, the cosine of beta, the cosine of beta, yes. So if we check here, we had the cosine of beta minus cos beta, but this is what I want here. The cosine of beta, this one, which is adjacent over hypotenuse, it gave us negative 7 over 20. This is the value that is corresponding to cos beta, this one. This is the answer. Negative 7 over what? Over 25. So this is the one that we want. Not this one. This is the one when we use the negative, this one outside. I want the exact value of cos beta. So we have that. Negative 7 over what? Over 25. So from the ratio of cos, here we used the ratio of sine. Now we are back to the ratio of cos. to the ratio of cos from cos, all right, from cos beta, we saw that the cosine of beta there was given as what? -7/25 from the adjacent over hypotenuse. This is from the bigger triangle, but referring to the same angle, but of the bigger triangle. What about from this smaller triangle? What is going to be the ratio of cosine of beta? The cosine of beta, according to the smaller triangle adjacent, the adjacent there is the one that we are supposed to calculate, which is x, over the hypotenuse. What is the hypotenuse this time? From O to T, which is what? 15 units. So you're going to have a 15. So this is what we have. So these two, there is no way they are equal. These two, they're equal. The cos of beta and the cos of these two, they're equal. So we can formulate an equation. Therefore, -7/25 is equal to x over what? Over 15. So just like the previous case, multiply by 15 this side, multiply by 15 this side, this can cancel. So therefore, our x is going to be given as this 15 times -7/25. So I want you to do that on your calculator. You are going to get -21/5. So our x, therefore, is -21/5. So therefore, what does it mean? Therefore, the point T, as we know that a point is made up of x and y. What is the value of x? It's -21/5. What is the value of y? We calculated y before, we got -72/5. Isn't it the point that we are given to prove here? This is exactly the point that we are given to prove, T here. This is the same T that we are having. So guys, be very, very careful. Very, very careful how you attempt your questions. Understand the information that you are given. Don't just answer the question. No, understand the information that you are given. So there we could have used this situation that the ratios are the same. So therefore, we can equate their equivalent answers because we know that these ratios are the same. Okay, then the other part, it was on B. Determine the area of triangle ROT. They are giving us the same situation to try and see if we understand this. All right. The area of what? Triangle ROT. Let us see. R to O to T. This is what we have here. From the point R to O to T. All right. If you check our diagram, guys, it's now ugly. This diagram is ugly. Let me just put it this way. Remember, this is our T. But what we need is this one. Okay. I'm going to remove this. What we need here is this part. From point R here to O to T, like this. This is the one they want us to calculate. It's what? Its area. All right. So if we check properly here, I'm just going to utilize this space so because if I move aside, guys, you won't understand me. This is 4.1 or 4.13. 4.13b. All right. So this is the B part. I hope you understand me. All right. They want us to calculate the area of triangle ROT. All right. The area of this triangle here is a non-right-angled triangle. It's what? A non-right-angled triangle. And we understand that the area of a non-right-angled triangle is given as half of AB times the sine of theta, or the sine of what? The sine of C, where C is representing the angle, which is the theta. All right. A and B is the distance that we're given. So if we check here, we do not have any angle, but what we have is the length from O to R. It's a horizontal. This one, it's a horizontal line. Guys, it lies on the x-axis. It's a horizontal line there. We don't need to use the distance formula. No, we know that from this point up to this point is what? 12 units. So this is 12 units. From O to T, it's 15 units, this one that we're given. So we have the length of this line and also the length of this line. This is what you're given, the length of this line and the length of this line. And we understand that the area is half AB times the sine of C. So we need the sine of the angle created by these two sides, which is the included angle, as we know, this one, the angle in between, which is our included angle. So from your properties of triangles, guys, this is what happens. I want you to understand this, and please do understand this. Please do understand this. We know that from our properties of triangles, it's like this. The ratio of a sine, if I am given, let's say I've got an acute angle here. All right, this is a triangle, whatever, it's a right angle triangle, whatever that you have. The ratio of a sine of this angle, which is the acute angle, is the same as the sine of the obtuse angle. These two angles which lie on a straight line, they have same ratios in terms of sine. So the ratio of this sine that we have here, because we calculated, remember this was the triangle that we were using before. We calculated its ratio of the sine and we got this as what? Negative 24/25. It is the same ratio of sine that we're going to have in this triangle. So meaning to say we have the sine of C. So we can calculate our area. So this is half of AB, which is the length. You can take from O to R. From O to R is how many units? 12 units times from O to T. Remember, it's ROT. You don't take OP, OT, which is 25 units, times the sine of C, which I said it is the same as the ratio that we got before. But this is area that we are calculating. We want the magnitude of area. So you take the value as a positive. You don't calculate area as negative, guys, all right? Area is always positive. You take the magnitude of what? Of area. The magnitude, that is what? You take the positive value. So this is going to give us, if you simplify properly on your calculator, you're going to get 432/5, which is the same as 86,4. That is 86,4 as a decimal, which is a square units. So you're going to just write even square units like that, or unit squared. That's the idea there. That was the idea on this area. So you see how they want to tempt you. They know some of us will be tempted there. So don't be tempted with these guys. Be very careful. Prepare yourselves for exams. Prepare yourselves for any test that follows. You must be for any test that is being given. Prepare for it. You know that you are guaranteed. All right. So this is what we are given here on 4.2. Simplify this to a single trigonometric ratio. Whatever that we are seeing here should give us a single trigonometric ratio. All right, let's see. How is that possible? That's 4.2. So we've got the tan of 225. This is an exact angle. You just need to see where does the angle 225 lies. The angle of 225, it lies in an angle that is, it's a positive angle. So you're going to take it anti-clockwise. That's 0 degrees, 90 degrees, 180 degrees, 270 degrees. We are back to 360 degrees. So 225 is in between 180 and 270, somewhere there. That's where our 225 is. So in this quadrant, we understand that tan is a positive from the cast concept. It is the quadrant of tan where this lies. So meaning to say, this is going to give us a positive tan of the acute angle. So it's positive tan of the acute angle, the reference angle. Remember, I was talking about the reference angle. So how do you calculate the reference angle in the third quadrant? All right. How do you calculate? If before you were adding it, so how are we going to calculate? We remove 180 from the angle that we are given because we do not have the straight line is not part of it. We are removing the straight line so that we just remain with this part only. So we have to subtract the 180 degrees of a straight line. 225 minus what? Minus 180 degrees. This will give us a 45 degrees. So we've got the tan of 45 as a positive because this quadrant is what? For tan. All right, then we've got plus the sine of 180 minus theta. Remember, I talked about this before. 180 minus theta is represented in what? In the second quadrant. That's where we have 180 degrees minus the reference angle. And in this quadrant is the ratio. It is the sine there. That is where sine operates. Sine is a positive there. Is the quadrant for sine. So the sine is going to remain as a positive. That's the positive of sine of theta, which is the reference angle. Remember, you have to reduce this. To reduce this to the sine of theta times cos 90 plus theta. These are now, we are now back to our special angles. We are now back to the application of our complementary angles. For cos theta plus cos 90 plus theta like this, it lies in the second quadrant. 90 plus theta is now into the second quadrant. And there, if you reduce in terms of sign, sign carries a negative there. So it will be minus sine theta. But if it was cos 90 degrees minus theta, this one, it is in the first quadrant. So it gives us sine as a positive. So sine will be a positive. But if you have 90 plus theta on a cos, it's a negative sign. All right. This whole part is over what? Cos 90 minus, this is the one that I was talking about, this one. So this one, it gives us a positive sign. Remember, from your complementary angles, cos must change to sine. Sine must change to cos. But for cos 90 minus theta, it changes to a sign, which is what? A positive, not a negative like what we saw here. All right. Then we have got times the sine of minus theta minus 540 degrees. So the first thing is that we have to reduce the angle of 540 degrees is equivalent to what? All right, let's subtract 540 degrees. Remember, I said if the angle is more than 360, we subtract 360 until that angle is within the what? The given region. So if we subtract 360, we are going to obtain 180 degrees. So this here is the same as the sine of what? Of minus theta minus 180 degrees. This is the same as what it represents. And what type of an angle is this one? Minus theta minus 180. It's a negative angle. Remember, this is the angle that lies in the third quadrant from this side. This is minus 180. Minus theta minus 180, it lies in this quadrant. Remember, negative angles, I said, these are the ones that move in a clockwise direction. As long you are moving in the clockwise direction, it's negative. So minus theta minus 180 is found in the what? In the third quadrant. Remember, in the fourth quadrant, it's minus theta like that. All right. Then this one will be theta minus 180. This one will be minus theta. It's going to be theta minus 360 degrees as a negative angle. You need to know your quadrants, guys. You need to understand them by all means. All right. So now let's consider this. We are in the second quadrant. That's where we have minus theta minus 180, this one. And it is the quadrant for what? For sine. Remember, we said in the second quadrant, it's for sine. So sine there, it's a positive. So this gives us the sine now as a positive. Remember, guys, I was talking about 180 minus theta before, but some of us might be wondering why we're having 180 minus theta. But now you're saying in the second quadrant, that is where minus theta minus 180 lies. All right, minus theta minus 180, it's a negative angle. Theta 180 degrees minus theta, it represents a positive angle. So a positive angle can be found in the second quadrant. A positive angle can be found anywhere. But the ratio now, the ratio of sine there is the one that we are talking about. Is the ratio of sine positive there? It is by default that in the second quadrant, it's only sine which is a positive. Whether the angle there is a negative or the angle there is a positive, sine in that quadrant is going to be what? A positive. All right, guys, I just hope if we have time, you see, time to talk about maths. There are a lot of things that you need to talk about, that you need to learn. All right, anyways, let's simplify. From your calculator, you can even simplify this. Tan 45 is 1. Plus and minus, here that will be a minus. Sine times sine represents what? Represents sine squared theta. Everything over what? You're going to multiply this part, sine and sine again. It represents what? Sine squared theta. That is what you're going to have. All right, so I think our quadrants, they are fine at this stage. We are no longer in need of these quadrants. We just need to know our trigonometrical identities, the identities that we have. Remember, from the identity of sine squared, that the sine squared of theta plus the cos squared of theta gives us a 1. So to obtain 1 minus sine squared, what does it mean? It means we had it transposed that side, so that we remain with cos squared minus theta, which is equal to 1 minus what? 1 minus sine squared theta. So if 1 minus sine squared theta is equivalent to cos squared theta, we can substitute it, guys, here. We can do what? Substitute. In place of 1 minus sine squared, we're going to substitute this. This is cos squared theta over what? Over sine squared theta. Remember, this is not a question for you to prove. This is a question for you to simplify to give us a single trigonometric ratio. So it follows that you must understand this. If it was a sine over a cos, if it was like this, sine theta over cos theta, as a single trig, it gives us the tan of theta. But the moment you have it as the cos over the sine, it's no longer tan. No, it's not a tan. There is now a cot. It's called a cot. The inverse of a tan. I mean, there are like 1 over a tan, which is a cot. Cos over sine, cot. Sine over cos, tan. Don't confuse these two. So this one, when it is a squared like this, it means if I put a squared here and a squared, this must also be squared. If this is squared, this must also be squared. So if we check, we've got a condition of cos squared theta over sine squared, which is this condition. So it's going to give us what? Cot squared theta, not tan squared theta, but what? Cot squared theta. So be very careful when you are revising. You'll be having memo, and the memo is showing you something else. Then you'll be wondering, what is it that is happening? Please do revise. Also, as an individual, learn to check your trigonometrical ratios. Aside, learn to work with your trigonometrical identities, solving trigonometric equations, simplifying and proving. We are supposed to know this. So guys, we shall have more questions to come, revising and also having introductions of topics. So let me know the areas that we can work on the comment section, so that we'll be able to work them as introductions and also as question papers. But for now, that's it, guys, from Mason African Motives. Till we meet again.